one, it says your soccer team wants to practice a drill for a certain amount of time each day. Guys, which plan will give your team more total practice time over 4 days and then over 8 days? So let's look at with plan 1 first. Okay, so plan 1 says 5 minutes today and then 1 minute more each day than the previous day. So on the first day, how many minutes are you practicing? 5, and then the next day? 6, and the next day?
7.
Next day? Next day? Next day, then 11, then 12. Okay, so let's add up for 4 days if we practice how many total minutes that's going to be. So you guys will need calculators today. So add up the first 4 days and then add up all 8.
Go, run. Melissa, can you get me one too? Olivia? Yeah. Just like throw it. Oh, thank you. That's for me. Okay, I don't know. Thank you. Thank you. Sorry, I should have thought
Okay, first 4 days, how many minutes is that going to be?
68.
No.
It's not going to be
For just the first 4 days. For all 8 days, I think that's 68.
I was so ready.
Yep, so 68 minutes for all 8 days, and then just for the first 4. I don't know. Yep, 26. Okay, so if you practice for 4 days, you'll have 26 minutes of practice time. 8 days, you'll have 68 minutes. Okay, so now let's look at plan 2. So plan 2, it says 1 minute today and then twice as much time each day as the previous day. So first day, it's 1 minute, then how many? Twice as much. 2, then the next day. 4, then the next day. 8, then the next day. 16, then 32, then 64, then 128. Yep. Okay. So if we just practice for 4 days, figure out how many minutes that is. Hmm? 15? And what about all 8 days? Uh-uh. 255, yeah. So you're adding up all of these numbers. Okay, so if I only practice for 4 days, which plan is going to be better? Yep, plan 1. But if I practice for 8 days, which plan is going to be better? Yep, plan 2. So, what these two things represent are, plan 1, since you are adding 1 minute every day than the previous day, this one is actually a linear function, where your slope would be 1. This one you're multiplying by 2 every day, right? So since you're doing that, this is an exponential function. So what happens is even though the exponential one might start smaller, over time it picks up speed a lot faster. So it tends to increase or decrease really fast versus this one that's still going to keep the same pace. Okay. So these two sections, the last two, are all about like equations and functions and stuff for exponents. So your objective is students will be able to evaluate and graph exponential functions. Guys, focus. So today is going to mainly be like the exponential functions, like the basic ones, graphing them whenever your function is like multiplying by 2 or multiplying by 3 or getting cut in half. And then the next lesson is going to be like if you're increasing or decreasing by percentage, how you would handle that. All right. So essential understanding for this, in an exponential function, the independent variable which usually is x, is an exponent. So a little side note on this, just because it has an exponent doesn't make it exponential, okay? So for example, y equals x squared, that has an exponent, right? But is the x the exponent? No, what's the exponent? 2, yep. So just because it has an exponent, that does not mean it is exponential. The x has to be the exponent. That's actually quadratic, which is another unit we're going to do this semester. Okay, and then the basic formula for an exponential function is y equals a times b to the power of x. A is going to be your y-intercept. And it's also going to be what the y-intercept is, which is your starting value. And then b is going to be your multiplier. So if something's doubling, it's going to be a 2. If it's tripling, it's going to be a 3, and so on. Okay? And then the x stays an x for the function. All right, and then what to look for on a table to tell whether or not it's exponential. And this is assuming that like the x's have a constant like pattern, like they're going up by 1. I'm not going to give you any tables where that's not the case, but just so you guys are aware, like if the x's are all random, then you're not going to be able to see the pattern the way you're supposed to in the y's either, okay? But the pattern is in the y's, so the y values, they have a common ratio. Do you remember what that means? What kind of pattern a common ratio is? Do you remember? Common difference versus common ratio? Is that familiar? End of last semester? No? Okay, so common ratio means it's a constant add or multiply or divide. And that's going to be in the y values. If it's a constant add or subtract pattern, which would be a common difference, then it's linear. It's going to make a straight line.
So it's always in the y values.
Yeah. Okay, on a graph, these are the 4 different ways that, like, shapes that this can have. So here's one, here's, like, the negative version of that one, this one, and this one. So it just depends on if, like, the right side is increasing really fast or decreasing really fast, or if the left side is increasing or decreasing really fast. But the behavior of these generally is that one end is going to either be going up or down really, really, really fast, and then the other one is kind of leveling out, and it approaches this thing called an asymptote. And it's not always the x-axis. It can shift up and down. But that is basically where, think about it like if I'm trying to get to that wall right there. If I'm only ever allowed to go half the distance to that wall every time, am I ever actually going to reach the wall? No. If I'm only ever allowed to go half the remaining distance, am I ever going to get there? No. So that's the idea of an asymptote. So it's usually 0 because it's going to get as close as it possibly can to 0. Like it keeps getting cut in half or thirds or whatever, but can never actually get there. So let me see how we want to write this. All right, so it's going to get closer and closer every time, but it's going to never touch or cross that invisible line right there, okay? So on a test, you want to make sure that your line is not touching or crossing that line. That's part of, like, you knowing about the graphs. Okay, so for the first example, does the table or rule represent a linear or exponential function? So remember, we're looking at the y values. We're looking at the pattern. So what's the pattern in the y values? Times 3. So since it's a multiplication pattern, is it going to be linear or exponential? Exponential, yep. All right, for B, what you're asking yourself is the x an exponent or no? No, so this is y equals mx plus b form, right? So what would this be? Linear, yep. So if the x is like on the normal level, just being multiplied to the 3, that's linear because mx plus b, right? If the x is raised as an exponent, that's when it's exponential. Okay, go ahead and try the next one. Okay. For this one, what's the patterns for in the y's? Yep, +2. So what's this one going to be? Linear, yep. All right, and then for B, what's that going to be? Exponential, yep, because the x is an exponent. All right, good there? Okay. All right, next one. Suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. The function f of x equals 30 times 2 to the x power gives the population after x weeks. How many beetles will there be after 56 days? So, a couple things. You're starting out with 30 beetles, right? That's why in the function, the 30 is the first number. That's always like your starting value / y-intercept. And then it says it's doubling each week. What's doubling mean? Times 2, so that's why this is a 2. Just so you guys understand how it was formed, okay? And then it says x is x weeks. And it's asking how many after 56 days. So what's my first thing I'm going to have to do? Huh? Yep, so 56 days has to turn to weeks, right? So how many weeks is 56 days? Yep, bless you. Pay really close attention to that. A lot of people get that wrong on the test because they just go too fast. All right, so now we're going to take our function and plug in the 8. Okay, and then figure out what that equals. Do you have it? Mm-mm. Did you do the eighth power or just times 8?
Oh, I just said times 8.
Yeah. What was it?
7,680.
Yep, 7,680 beetles. Okay, and then go ahead and try the next one. You good on this one? Done? Okay, so what are you going to have to do first on this one? Anybody? What do I have to figure out first? Yep, how many half years, right? So 3 years is what? Yep, 6 half years. Okay, so we have f of x equals 20 times 3 to the x power. Okay, so what did you guys get for that? Yep, 14,580 rabbits. Do you have any questions on that? Okay, so make sure here that you're doing the 3 to the 6th power first and then doing times 20 or putting it all in at once. But make sure you're not multiplying first, okay? All right, graphing now. So we're graphing y equals 3 times 2 to the x power. I typically start at 0 and do the positives first. I don't know why. I just don't like doing the negative ones first. So if I plug in 0 for the exponent, I have 3 times 2 to the 0 power. What's that going to be? 3. Yep. So, and remember, that first number is always your y-intercept. So that's always going to be the y value at 0. So then when I plug in 1, what's that going to be? 6, which makes sense because we know our multiplier is 2. So you should be multiplying by 2 for your pattern. So then what's the next one going to be? 12, yep. And then for the negatives, this is going to be the only time that we're okay with you doing decimals. For these, just because decimals are a lot easier to like know where to plot them instead of fractions. So when I do -1 for the exponent, what's that going to be? Remember, if you're multiplying by 2 this way, you're dividing by 2 going this way. Yep, 1.5. And then what's that going to be? Yep, 0.75. Usually I do 2 decimal places rounded if you end up with a really long thing, okay? All right, so at 0, we're at 3. 1 was 6. 2 was 12. And then we did 1.5, 1.75. Okay, so if you see this shape, this right side is going to be increasing really fast. And then this left side is going to get as close to 0 as it possibly can, but it should never touch or cross it. So make sure your line is not touching or crossing the x-axis on that side. Because going to the right is multiplying, right? So it's going to get big, 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 big. Going to the left is dividing, so it's going to get smaller, smaller, smaller. Any questions on that? Okay, go ahead and try the next ones. Okay, let's go. All right, so for this one, 0, you get what? What do we get for 0? 0.5. Yep, and you're multiplying by 3 each time. But what do you get for 1? Yep, 1.5. And then what about 2? 4.5. Yep. And these are going to get really small. So what do you guys get for negative 1? Huh? Point 0.17. You said okay, yeah. Okay, and then what about negative 2? Yeah, so like 0.05, right? Okay. And then for this one, it should just be the same thing but negatives, right? All right, so on this one, negative 2 is really close to 0. Negative 1's a little higher, but still 0's at half. 1 is at 1.5. 2 is at 4.5. Okay, so this one's going to kind of level out on the left side, and then as it goes to the right, it's going to be increasing more and more like that. And this other one's just basically going to be like the inverted version of it. So here, here. Okay, so it's still going to get really close to the x-axis on the left side, and then it's going to decrease really quickly on the right side, like that. Does that make sense? Yeah? Okay. All right, so we're just going to do these next ones just for just practice, just because they're good for like the common final that you guys have to take. Like they're worded really similarly, even though they're easy merit, we don't know that anymore. All right. So this one, select yes if the following functions pass through the points 0, 2, and 250, and no if they do not. So first, we're just going to check the first point 0, 2. If that doesn't work, then like we're not going to even bother checking the other one. So let's do. Okay, so for the first function is a, y equals 10 to the x power. So plug in the x and the y. So 2 equals 10 to the 0 power. What's 10 to the 0 power? 1, so does that work? No, right? So we're not even going to check the other point because it's not going to work. Okay, b is y equals 2 times 5 to the x power. So 2 equals 2 times 5 to the 0. What's 5 to the 0? What? 1. So 2 times 1, so 2 equal to 2 times 1? Yes. So now we have to check this other point to make sure this one works also. Okay, so for that point, the y is 50, and the x is 2. Okay, what's 5 squared? 25. So does 50 equal 2 times 25? Yes, so this one's going to be a yes. Okay, let's try C. That's y divided by 2 equals 12x plus 1. So we're using 0, 2. So 2 divided by 2 equals 12 times 0 plus 1. Okay, 2 divided by 2 is 1. 12 times 0 is 0 plus 1. So does that work? Yep. So let's check the other one. So that one's 50. And then x is 2. So did that one work? Yeah? Okay. Sounds a yes. then dy divided by 3 equals 4x plus 1. So 2 divided by 3 equals 4 times 0 plus 1. So 2 divided by 3 equals 0 plus 1. So does that work? No. Okay. All right, next one. Okay. The function f of x equals 2 to the t power plus 2 represents the number of leaves on a plant as a function of the number of weeks. Which of the following statements are correct about the function? So just so you guys know, this is messed up. This should be f of t. So, I mean, then this was actually like screenshotted from the practice test. So they just made an error. But the number or the variable in parentheses should always match like the input variable. Okay. So either way, t, like the input, is going to be the number of weeks, the time, and then the answer you get is going to be the number of leaves. So for A, it says the plant has no leaves initially. So let's figure out a point for that. So what would initially be after how many weeks? 0, and then no leaves? That would be how many leaves? 0. So we're checking to see if that works in there. So 0 equals 2 to the 0 power plus 2. Does that work? No, right? Okay, so for B, it says the plant has 4 leaves in the first week. So what point would that be? So first week, so 1 week, and then 4 leaves. So we're going to do 4 equals 2 to the first power plus 2. Does that work? Yes? Okay. Okay, the plant has 10 leaves in the third week. What point is that? Ten leaves in the third week. What point? Yep, 310. So we have 10 equals 2 to the third power plus 2. Does that work?
Yeah.
Yep. In the fifth week, the plant has 32 leaves. What point is that? 532. So 32 equals 2 to the fifth plus 2. Does that work? Nope. And then the second week, the plant has 6 leaves. So 6 equals 2 squared plus 2. Does that work? Yep. So you should have B, C, and E. Okay? Good? All right. Lesson check. Okay, do those. Okay. What's answer number 1? Come on, guys. Exponential y. Yes, you do. Yep, x is the exponent. Okay, and then what do you guys get for number 2? Yep, 48. All right, and then for this one, your y-intercept is 4. And then 1 would be 2, 2 would be 1. And then -1 would be 8. And then 16 would be -2. So it should look like this.